Take a second to look at the screen you're holding right now. How exactly is the video data you're watching finding its way to your specific device? At its core, the answer is a computer network. You can think of it as a digital neighborhood, a group of devices connected together for the purpose of sharing information, like a single document or a central printer. To make sense of how these connections happen, we use 3 specific labels to measure their physical size: LAN, MAN, and WAN. To understand how they work, we're going to take a physical journey. We'll start right inside your living room, step outside to see your entire city, and eventually pull all the way back to look at the planet as a whole. Along the way, you'll see a consistent rule in action. Every time we stretch a network to cover more physical ground, we gain reach, but we have to pay a price in speed, cost, and complexity. Let's start at the smallest scale, right inside your house, school, or office floor. Because the physical space is tightly contained, the network is too. This local area network, or LAN, directly connects your laptop, phone, and smart TV to a central router. Because data doesn't travel far, transfer speeds are incredibly fast, cheap, and highly secure. But if that router loses power, the entire system stops dead. A LAN is a highly effective tool for sharing personal resources quickly and safely, but on its own, it remains an isolated island. To leave that island, we have to look outside the building and view the whole city. This is the Metropolitan Area Network, or MAN. It provides an overarching grid linking dozens of isolated networks across neighborhoods. It's incredibly useful for a business sending large files to a branch office across town, traveling much faster than out into the wider world. Laying the physical tables and managing the routing across an entire urban environment is highly expensive. It requires specialized professionals and serious budgets, usually funded by large organizations or local governments. A MAN serves as the digital civic glue. It takes thousands of separate, isolated homes and offices and weaves them into a single, functioning municipal system. But what happens when you need to reach beyond city limits? For that, we must zoom out and look at the entire planet. To cross oceans and continents, we rely on a wide area network, or WAN. This system is specifically designed to take all those city-wide MANs and local LANs and stitch them together on a global scale. The internet is a wide area network. City networks are tied together by massive cables and satellites, allowing a North American laptop to communicate with an Asian server in real time. But crossing the globe reduces speed, costs billions, and exposes data to security threats. Ultimately, WANs trade away local speed and private simplicity to achieve reach that spans the entire globe. These 3 networks aren't separate competing systems. They act as overlapping layers of a single, massive physical structure. If we look at this comparison table, the trade-offs become crystal clear. A LAN is restricted to your home, but gives you very fast speeds at a low cost. A MAN covers a city with moderate speed and high cost. And a WAN gives you global reach, but at the expense of slower transit times and massive setup costs. This means when you connect your phone to the router in your living room, you are physically tethering yourself to a tiered architecture that spans the globe. So the next time your device says connected to Wi-Fi, take a moment to picture the invisible cables and signals stretching from your room out into your city and across the ocean floor. If this breakdown helped you see the digital world a little more clearly, please hit like, subscribe to the channel, and let me know in the comments what system you want me to explain next. I will see you in the next video.